Welcome to the ADS Workbench video tutorial series. In this lesson, we will be using the ADS Workbench to set up a 3D multi-stage steady simulation. One of the strengths of the ADS tool suite is its ability to go from designing and simulating individual rows to combining those rows into stages and simulating their interaction. The ADS tool suite makes it quick and easy to order these rows and then simulate the problem on one CPU or across multiple CPUs using MPI-CH2. Before starting a 3D multi-stage simulation, you will first need to have created a workbench case for each of the rows. We will be using the single row cases that are included as samples to create a 1.5 stage turbine simulation. Please refer back to the tutorial on setting up individual 3D row simulations if you have questions or have not done it already. It's a common mistake to define the end walls discontinuously at the row interfaces. If the end wall definitions do not intersect at the interface, the resulting solution will be incorrect. We recommend using the same end wall definition for all rows if possible. Let's start the workbench. First, let's review our workspace. In the Project Explorer, here, there is one project called Samples and 3 individual row case files that represent part of our turbine that we wish to simulate. Row 1X represents the first vane, row 2X represents the first blade, and row 3X represents the second vane. Using the workbench to create a 3D steady case is a snap. From the File menu, select New 3D Multi-Steady Case. Let's name our case Turbine 1.5. And let's put it into the Samples directory. Click Next. First, change the number of rows that make up our case. Let's change it to 3. Next, add the rows by the relative location, starting from upstream to downstream. Let's set the mesh parameter settings. Generally, you'll want to keep the same mesh generation settings that were used in the single row cases. You may choose to tweak the settings for each of the rows. The ADS Workbench allows you to change the number of points to the upstream boundary and to the downstream boundary for each of the rows. It also allows you to change the number of points across the airfoil pitch. Now set your flow solver settings. First, take note that there is a new option called prun. This parameter allows you to select parallel or serial execution. Select parallel if you have multiple CPUs to execute on. Otherwise, serial execution will be better. For the rest of the settings, we will just use the defaults. Click Finish and the case is built. If there are any problems, you will see them in the console window. Click Run Wand or Generate Mesh. Click Refresh Workspace, and you will see a new file called Mesh Debug. You can open it, and any error messages that might have occurred will be displayed here. If there are none, you will see End of Job with Code Wand. Now let's run the Leo flow solver. And we can see the case is now executing. Once it's complete, click Refresh Workspace, and now you will see all your convergence data and your performance data. In the case that you make a change to the underlying individual row cases, you will need to refresh the 3D multistage case in order to reflect those changes. What you will do is you will click Modify Case, and you will see there is now a checkbox that you can click that allows you to refresh the case with the latest configuration data. Click Finish, and everything will be rebuilt. Finally, let's create a new case from this, except this time let's run it serially. Let's call this case Turbine15 serial. And let's click the Use Settings from an existing case. Let's also put it in the samples directory and click Next. Now let's change the prun settings to serial and click Finish. If everything is okay, you will see Build Successful and a new directory in your samples directory called Turbine15 serial. Here you will notice there is a new command you can run called Run ADS-Util. You will need to run it in the order of generate the mesh, followed by ADS-Util to combine the restart files into a single restart file, and then you will run the Leo solver to execute the single serial case. And that's the end of this tutorial. If you have any questions or problems, please visit us at www.aerodynamic-solutions.com. Check out the ADS University and FAQs. If you cannot find your answer there, join the community forum and post your questions there. Good luck!